Hello guys and welcome to class. Today is a Sunday and I don't know what day or what evening, hopefully Monday evening, you'll be watching this video. Or any time thereafter when you need a refresher on how this works. I realize that naming ionic compounds is still difficult for several students. Several people have talked to me about it, and it's hard to move on to writing balanced chemical equations when we're not yet good at naming or writing the actual symbol for a compound. So I'm going to put up this short tutorial. Hopefully it's helpful to you. We're both going to write the symbol when given the name of an ionic compound, and then we are going to write the name when given the symbol for an ionic compound. Now, I'm sure you remember this worksheet this worksheet that I gave you. And with it, I gave you this set of Chapter 6 notes on the steps for naming different compounds. You'll need your periodic table and also a list of common polyatomic ions. The first step is to write the symbol for your positive ion first, followed by the symbol for your negative ion. So let's go ahead and do that. We start with iron, which you can find right here on your periodic table. You can see the symbol is Fe. It's important that the first letter always be capitalized, the second always lowercase, so that we know this is one element and we don't get confused. Now, let's look up the symbol for phosphate. Phosphate isn't a single element. Instead, it's a few elements bonded together to make an ion. You'll find it on your polyatomic ion list, and it says phosphate, PO4. So, it's made of potassium and 4 oxygen atoms. That's a phosphate ion. Now we have to look at charges to make sure that our overall compound is neutral. The charge for iron is already given to you. It's 2. That's what the Roman numeral is for. So let's use this to help us to figure out how we can name this ion. Our charge for phosphate is a -3. We want to have the same amount of positive charge as negative charge in the compound in order that the compound be neutral. A simple trick when working with bigger charges like 2 and 3 is to simply cross them. So let's try that trick now. If we have 3 iron ions and each iron ion has a charge of 2, well, 3 times 2 is 6. We have a 6 positive charge on this side. If we have, and I'm going to put parentheses so I know that I'm talking about the entire ion, if I have 2 of this phosphate ion, and each phosphate ion has a charge of -3, my total charge on this side is -6. Positive 6 and -6 cancel each other out. Its overall charge is neutral. So my symbol for iron 2 phosphate is Fe3PO4 in parentheses times 2. Now let's work on naming an ionic compound. We follow the same steps, but we're using words now instead of symbols. Al, capital A, lowercase l, is our first symbol that we need to identify. On your periodic table, you'll see that Al stands for aluminum. I normally stands for iodine, but because this is part of an ionic compound, we replace the Ne ending with a De ending, and we call it iodide. Finally, we look to see if we need to add a Roman numeral. If aluminum was a transition metal, we would need a Roman numeral. But as you can see, our transition metals end just before we get to aluminum. So aluminum is not a transition metal. We do not need a Roman numeral when we write aluminum. So this must be the completed name, aluminum iodide. Let's look at our next one. Cr is the positive ion, and that we can find on our periodic table. And I didn't highlight mine yet. It's right there. Cr stands for chromium. And as you notice, because it was in that indented lowered part of the periodic table, it's one of our transition metals. So we will need a charge. I'm going to leave a little bit of space, and we're going to name the other ion, and then we'll figure out what our charge is for our chromium. NO2. We can look it up on our polyatomic ion list, and I am going to highlight it again for you so I can show you. And since it's polyatomic, we do not have to put on a DE ending. That is only when it's monoatomic. In the case of iodide, one other kind of element. With a polyatomic ion, we're able to keep the name as is. And you can see NO2 is nitrite, and it has a negative charge. Nitrite has a negative charge, and because of this number 3 outside of parentheses, we know that we have 3 nitrite ions in this compound. 3 times -1 is -3. So we know that on this side, our charge must be -3. Because we know the compound is neutral, as all ionic compounds need to be, our chromium must have a charge of +3. Because chromium is in the transition metal section, we need to say the charge of the ion in Roman numerals when writing the name. We can call this chromium 3 nitrite. And I can be all fancy with my Roman numerals having their caps on them. Alright guys, I hope this was useful to you, and I'll see you on another video here shortly.